I've just started the recording locally. Hopefully that's okay with everyone. Let me know if it isn't. I think we should get started now. So over to you, Lupcho.
Okay, thank you, David. So welcome everyone. This is another of our webinar series, webinar program. We're going to shortly dive into interesting topic in regards to one of the interesting integration connectors we use. The topic is how to use a repository proxy connector, and you will hear more details about it. But first, my name is Lupcho. I'm working for ING as a senior engineer and solution architect. And in the context of Egeria, I'm Egeria maintainer. And David, can you just quickly also, do you want to introduce yourself as well for the audience?
My name is David Radley. I'm an Egeria maintainer working for IBM. I've been working on Egeria since the very beginning. So I'm really happy to be presenting with Lupcho.
Cool, thanks. I mentioned the webinar program. This is just the series for this month. And I believe it is going to be the last one for this year, according to our plan. And yeah, we'll come back with the new plan for next year. We have a lot of new topics to share. So yeah, stay with us, stay tuned for this. The topic for today, or the agenda, is all around the repository proxies. And the agenda is going to cover first a little bit more, giving a context first about what it is, what we mean by repository proxy. It's a function, what is its purpose, bit of internals, what are the components within, and maybe what since it is an integration component or application, what choices you can make or to have an optimal implementation there. And then we are going to continue a little bit with the more practical knowledge and experience based on a couple of, at least two major styles that we use to already get to some value out of certain technologies. First one will be going a little bit over what we use in ING and the experience sharing with this style of integration and the commercial technology coming from IBM, so the data integration in information governance suite, well known as IS-IGC and its metadata capability. And we're going to talk about how we started with this, how we used it, and maybe ways to improve it in future, or how we did improved in some ways. Then I'll hand over to David to talk about the caching repository proxy connectors, which this is a new pattern, quite interesting one. Can compensate also for some of the limitations we had in the past. And finally, we are going to talk about some of the other known implementations of this same approach across different technologies that we know of or we use to maintain. But more about that later. Okay, I think we're good to start. So what is the repository proxy and what we mean by this? In our ecosystem, in Egeria, we have this different types of server applications or roles of servers can play in the whole ecosystem. And a repository proxy, you can see it is in this hierarchical representation under cohort member. If you are familiar with the concept of a cohort, this means that it is already clear that this capability or this server, this software capability will play a role in metadata sharing. So since it's a cohort member, helps us in a way to share metadata or exchange metadata. This is how this can be done. It depends on really underlying technology. But Again, about the purpose, well, we all know in real life, in all the organizations and in different environments, metadata is always present in some different either technology silos or different platforms, and it's just managed there independently. And of course, one of the most important goals of Egeria is to bring that to open or to share it across. And when it comes to third-party technology, the way to do it is through a repository proxy. And this pattern or this style of integration, what basically means it is a implementation of an adapter for the third-party technology and the ways the third-party technology manages metadata. And it is an attempt to make it open or expose the metadata through this pattern. With the goal out of this, it's of course, the benefit is obvious. We, as I said at the beginning, we do want this metadata to be out on the shared. Yeah, that's how we will get there with this approach. So what you see on the picture here, it is how this is positioned. This software server application is positioned, and it always sits in between the third-party technology and in the rest of the Egeria ecosystem. And it talks to the cohort, so it is part of the or complies with the protocol that we have established for cohort and what cohort member means. But on the other side of it, it is really connecting or having its underlying connection towards the third-party technology, which for itself can be just perfect for the job. But as I said, we do want to expose and create a value from the metadata it contains. So for what does it mean? There's this yellow box here, which we call a repository proxy. This is in Egeria terms how it is built, all those subsystems all together, but actually more the building blocks that you see here in focus, those are what make or what's the ones that support the function of repository proxy. And with these building blocks enabled, we are able to support the function of repository proxy. Main thing is that the connection towards the third-party technology goes always with the connectors. So that's why I want to focus on parts of this that are key to implementing a repository proxy. Those two yellow boxes on the right. So first and most important is the repository connector itself. This is the standard interface that each and every repository should implement to expose metadata in a standard way. And then next to it is what we call the event mapper. It is to allow external technology to share the metadata in a proactive or active way, or what we call active integration, by using event mechanisms. When it comes to these components, they can play a different role, and it really depends on what is the capability of the underlying technology. As I mentioned, the key here is the repository connector and the implementation and its implementation. And this is the minimum that is important for one repository proxy to be functional. So it means that it will implement the common interface, and with that it will be able to simply take a part of the federation, or what we call support for federated queries, be able to respond on different queries or requests for metadata from other players in the cohort. But this is not the only thing. An event mapper, which is the second important component or connector, is also allowing us to share the metadata, this time through event mechanisms. And with this, they complement each other, and the optimal integration will be to have them both in a same solution, or in the same repository proxy in this case, because only then we will have optimal active integration in place. However, the practice we will see later on is that there are different techniques that we have to implement on top of these choices, because different technologies just don't provide us means to implement an event mapper. That's why at one point this became as an optional component, and we have to compensate for it. So if I dive a little bit more about the different styles, and this leads me to actually the concrete practical implementations later on about these two components. So if I look at their list of responsibilities of what they actually do, we will see that some responsibilities are shifted, and with that we can have slightly different flavors or different integration styles. The standard one, which I'm going to talk about, and we have it implemented as an open source connector for IGC, is it's what we mostly have tested and used in ING. And that one actually, how it works basically, I will just go through quickly what it does. So always runs as a local repository, attempts to represent the third-party repository as a local repository available to the others, provides the standard metadata collection exposure, as I mentioned before. It has the responsibility to implement the whole mapping logic between the proprietary types and what we call OMRS, common language types in Nigeria. And it can also have some caching logic, but it really heavily depends on the underlying technology. And then in some way accesses to the external technology. And then the event mapper is responsible for processing inbound and outbound events. Most of the time, ideal cases, the third-party technologies will have some eventing mechanism, but in practice, we see that not always this is working well, or it is limited to some extent. On the other side, we can see the slightly new and improved or advanced repository proxy style of implementation, and this has slightly different approach. So delegate some of the responsibilities you can see there delegated to the event mapper, and some mapping logic happens there, with addition that there will be caching layer in between and ability to poll metadata, and which is quite good for situations where maybe the third-party technology will not provide directly events, and we can compensate with this different technique. But more about this in the separate section. So I would like to talk about a little bit now more about what we have seen or experienced from the practice using the open source IGC adapter. So it's a project or a sub-project component connector that is available in the under the open source community. This was created really at the time to allow us and show that we can actually benefit out of third-party technologies such as this one. few characteristics on the, I will not go into really details about what this IBM stack offers, but just few characteristics on the integration point, which is the identified, the IGC is identified as integration point, and that is the actual metadata repository. So it is a Java multi-tier application that provides different tools. For us, the important part is the metadata repository. It has its own REST API, exposes standard operations on metadata. In a generic way, I will just call it. It also allows us to do advanced search operations, but unfortunately, it has limited event notification interface or interface that across different versions, and how it was evolving was not providing a stable or stable interface for us to build upon it and have a stable event integration, if you will. Just for you details how it works based on this open source integration connector. So the requests coming out of Egeria are just coming through this repository proxy implementation through this adapter connector. They're reaching the metadata collection, which is an implementation of a local repository, and basically they're forwarded to the external technology or the external API, and then the mapping logic on the way back from the external technology happens within the adapter. On the right-hand side, you see that the information server or the whole suite has its own workflow, and this technology is Egeria does not influence on that workflow. Basically, there is a standard business as usual operation happening there. Metadata is authored and created, but also made available through the IGC adapter on the left-hand side. And that's how we have it deployed. Basically, this is this simple. As I mentioned before, you will not see here the other component, which is the event mapper, simply because of the limitations or the instability of that interface at that point in time. So what does this mean for us? Without having this event mapper, we're basically, another thing that I forgot to mention is that this pattern you can see here is read-only. Basically, what this does not support is this supports only one integration or metadata flows, basically reading metadata from the third-party technology and exposing it. But it does not support the other way around, so capturing and pushing metadata towards the third-party technology. And again, this is because the third-party technology or this IBM suite does not really work well with the concept we know as reference copies. So you are still able to create metadata, but not to have it as immutable metadata, and not therefore cannot comply with this requirement of the protocol. So what does that mean? What does these two limitations mean for us? Well, first, it's obvious we don't have updates distributed across the cohorts of cohort members. So they're not actively notified about changes that are happening in the external technology. Then we have to somehow compensate for it. I'll talk a little bit later about how that implicates. Obviously, as well, with no event mapper to do the other way around, we are not sending this to all the changes are not propagated back, or we are not able to distribute metadata maybe from different systems across the cohort back to IGC. And just a reminder, this is all for the open source connector and this integration style. Later on, I will mention that there is another integration pattern for this technology. finally, metadata, then what we benefit from this adapter is that we are getting the metadata always through federated queries, and then this has some, of course, impact on performance, because every time we want to do something, build on top of the metadata some use case, or construct more complex structures, it has its price with impact on performance, and we do not, we're not able basically to build on top of this performance solution. That's why we are also looking into different approaches, some of them quite interesting, mentioned later on in the other caching pattern. So for some of these, we managed to compensate a little bit. So at the first, the event mapper was considered to be a required component. So the design of Egeria was in a way that it always expected that to be present in a repository proxy pattern. But later on we learned, so we also made it optional. But what that means then, not having reference copies means that you can, or if you create reference copies during retrieval, you'll be not able to maintain those if you don't have a proper event propagation. So from there, we made this component optional, as you have heard before, but that also means that that we don't store the reference copies, and it's always the entities are retrieved at the point of querying. So from the external repository. This doesn't mean that we cannot still use and continue to maintain the metadata around the metadata that comes from an external system. We are still able to provide and guaranteed consistency on retrieval of metadata, and implement some automated processing. Maybe you are familiar with anchoring mechanisms and last change tracking of last changes on entities retrieved. So this is still possible, but for this we needed to also do another enhancement, and that is that we are storing the entity proxies now. We are storing the classifications also for entity proxies, because we don't have the full entities or copies of those. And with this, we are, as stated, still able to augment and make use of the consistent access towards metadata. So in a way, we compensated for the thing that was not, the events not being available out of the technology. However, at the end, I will just mention that it is, at this point, is not really this point is not really an optimal solution. We are running this, but it's still we see it as a value, because with at least the metadata is exposed, which is the most important thing. And about the performance, there are different approaches we are considering. I think even the caching pattern can help in some aspects. So that integration style, more about that integration style, I think you will hear from David soon. But last and not the least, there is, however, better or more proprietary integration, which is through Event Mapper, that is coming of one of the latest version, and still from the product itself, so from IBM IGC. However, that is still under testing, and that one only offers us event mechanism and does not offer us this federated query support. So it is a slightly improvement, but not complete solution. I want just to mention it. And for future, of course, we're considering of introducing some more advanced techniques. Maybe the caching repository is going to help in some regards. So next is exactly that integration style. And David, you can please continue.
Yep, I'll share my screen. I'll just put it onto the. Does that look okay to everyone? Can you see the next? Yeah.
Yep, looks good.
Okay, thank you. Are there any questions at this stage? If you have any questions, just pipe up while I'm talking. So this section, contrasting with the pattern that Lupcho has explained about how the IGC made some compromises from the ideal repository proxy. This is a slightly different style, which has made different compromises. But the main thing is that it still allows you to bring your metadata into the Egeria ecosystem so that it can be shared and you can do integrations in this sort of easy open way that Egeria enables. So why did we start thinking about a caching pattern? Well, the requirement came to us that what we wanted was to be able to have connection to the metadata in a Hive metastore. So not just Hive metastore as supplied with Apache Hive and the associated metastore, but also one in the IBM Cloud data engine, which provides a Hive metastore API. And there are many other implementations out there that seem to expose this API. So we thought if we can get a connector that works for Hive metastore APIs, we can at least use that pattern, if not the connector itself, to be able to talk to these other implementations. So the restriction we had for the particular stakeholders that we were talking to was that the recipient repository in the cohort did not support queries. So as you can see from the IGC pattern, the only thing that supported was queries. And our requirement was that we didn't support queries. So we couldn't use the standard pattern. So we actually went to use an event-based pattern, but not the standard event-based pattern. And that's why this is slightly different. So first of all, we came up with this pattern and we thought we'd try it out first on a file system and do a sample to prove that this pattern made some sense. So the pattern is, it still has two connectors. It has a caching repository and it has an event mapper. So the event mapper has a polling thread and it goes to the third-party technology, in this case, the file system, and then it maps the content of the file system into entities. So entities, as you're probably aware, is the, which Lupcho showed you the picture of how entities fit. Entities are the sort of objects, the things within Egeria that are connected by relationships. So we create entities and relationships representing the assets on this file system, so the files. And that's done in the event mapper. So every polling interval, we see if anything's changed on the file system, grab that content, change it into the open format, the Egeria format, and then we send out a batch event. A batch event is one of the types of events that allows us to specify a list of entities and a list of relationships to push out all together. It's used prior to this primarily as after we've had some sort of loss of connection and we want to bring back content to and let the rest of the cohort know what the latest content is. What we also do is we store that content into a caching repository. So what is a caching repository? It's really a thin wrapper around a native repository. So there's actually, so we're talking about two different types of repositories here. We've got the native repository, which means that it stores its content in the Egeria format. It actually stores natively entities and relationships. So we have some implementations. XTDB is our preferred one, and that does that supports temporal queries, which means that Egeria can actually support that capability. We also have Janus Graph, which you can have. You could have that as an in-memory, in both of those as in-memory, or you could have that as persistent. The in-memory one is literally, as it says, is something that was written, that Mandy wrote as part of the Egeria code base to just store entities and relationships in maps. So the preferred one that we would want to use is XTDB. But I'm contrasting the native repository proxy with, the native repository and with this repository proxy, which is actually a thin wrapper. So it looks like a repository proxy, but it actually, every time it gets, you'd say add an entity or add a relationship, it stores it within the native repository. So you might think, what's the point of that? But the point of that would be that because we have a cache of everything up to now, any query that comes in, we can just honor those queries, those searches or gets by going to our cache. We don't have to go to the third-party technology, which would have been the way that IGC would have supported those queries. And though our requirement didn't actually ask for us to provide queries, it made sense for us to do this because it allowed us to see what we had easily, and it allowed us to visualize it using the user interfaces that we have. There's a repository explorer that we have in the Egeria UI and the ecosystem UI that allows you to look at the contents of the entities and relationships on a per server basis. So this was an easy way to quickly check what we had. And it actually made it much easier to code, because a lot of the complexity in creating a repository proxy connector is that you really need to go through every find command and permutation around the entities and around the relationships and map each of those options through to the third-party technology and then issue the query in place. But here we don't have to do any of that mapping. We have the polling thread that just grabs the content and then puts all of that content in Egeria format into the calls the repository proxy, which then stores it in the native repository. And I've just put this is a public repo, so that is the GitHub URL for this file sample. So then we thought, well, that went reasonably well. So we'll go ahead and connect this to the HMS, the Hive Metastore, using really the same ideas as we did with the file, except here we can't just issue a file call. We need to use the third-party technologies API, which is a Thrift client, which is supplied by the Hive Metastore open source project. It's an Apache project. Other than that, everything is the same. The only bit that we need to do is do this mapping of the third-party technology. And if you want to look at these things, here are the GitHub URLs so that you can investigate these. You can, if you find bugs, you can raise issues. You can download them, clone them. You can play with them. If you want to try this pattern, you can download and start playing. So so that if you are development inclined, then that's where to look. So because this is all about caching and polling, I was going to basically go into a little bit more detail about caching, then a little bit more detail on polling. So the caching repository Lupcio mentioned these things called metadata collection IDs. So we have a metadata collection, and that really represents the metadata repository. So in this case, we're representing the Hive Metastore as a metadata repository. So we want to mark all of those entities that we expose on the cohort with an ID that says they all come from the same repository. And then when the recipient gets those events, they will create the reference copies, the read-only copies of those entities and relationships. And the idea is that they wouldn't update them. So the contract when you're in the cohort is that those reference copies are read-only, so that the only person that would be updating them would be the Hive Metastore, which makes sense. So Hive Metastore, you add a table, you would expect that add table information to percolate through the cohort in this event, and then the other end would see that representation of the new table in entities and relationships, and they wouldn't be able to update those to change its name or anything, because that really wouldn't make sense. The responsibility for doing that is the Hive Metastore itself. So this is just saying that because we actually, when we have a native repository, it would have its own metadata collection and its own metadata collection ID. So those are actually, has got dash embedded on the end, and the one we expose on the cohort all have the entities and the relationships we expose on the cohort all have this metadata, this outer metadata collection ID. And furthermore, one of the things that we have around Egeria entities, many of them, if you're a referenceable, which is a subset of one of our types, so most is that they have a qualified name. This is a readable, unique name that every referenceable should have. And entities like relational table and relational column and database and things like that, they're all referenceables. So they all need, as much as possible, a unique readable name. So in the case of IGC, they actually had, they did need a qualified name as well, but they did have a unique identifier, a RID, which could be used. So every entity has a unique identifier, which is called a GUID in the Egeria ecosystem. So we didn't have an obvious way of getting a GUID. There wasn't an obvious unique number that we could associate with all of these the entities we needed to create. So what we decided to do was create, as much as possible, a unique string, which would be the qualified name. And we have a prefix that you can in the configuration that you can specify. And then we would create a number from that would be unique. So a base 64 number that should be unique because it's keyed off this name. So that's how we create that's how we try to get unique qualified names and unique GUIDs, because we're talking with a system that identifies its content using names and doesn't have these unique IDs. And this is showing that this would be the home repository would be this metadata collection ID, which is the one that matches here as well. And for the polling side of things, we've actually split it up into, the code is split up into two classes, sorry. There's an abstract top level class that does most of the work, but it's technology independent. And we've only got two technology dependent methods. So when we want to connect to the third party or get all the tables. So, and there are technology independent representations of the tables that have technology independent representations of the columns in a simple way that we've introduced with these two mappers. So in this way, we can have a very limited number of a very small class that actually does the technology specific stuff. So that's the idea around that. And this is the polling part. So the event mapper connects to the third-party technology, gets the tables and all the columns underneath them, maps them to Egeria entities and relationships, and then sends out the batch event, as we've said. And then, well, it sends out two types of batch events. One's for all the entities above the tables, including the database and the like. And then one for one set of entities and relationships around each table. And then we wait. It's possible to not specify a polling interval, so you just do it on startup, if that's what you want, or you can specify a polling interval. So this is, when I mentioned there's two types of batch events. This is what the top one is when I said above the table. Then this has a connection, it has a schema type, and I think that's the database. Yeah, this is the database, and this is one using when connecting into the data engine, which is the IBM Cloud endpoint that I talked about, which is which uses the default catalog of name of Spark. So then we have another event which has all of these relationships and entities for the column and the table. And here, if you're familiar with the type system, you'll probably think this doesn't look quite right. This is actually using the deprecated types, which, if you followed the Egeria sort of history, originally when we set up schema attributes and schema attribute types, we had the types separate from the attributes. And we made an optimization where we specified that we thought, well, we've got two sets of entities we have to create all the time for every time we have a schema attribute. We had an optimization whereby instead of having a second entity, we would actually specify the schema type information in a classification. This is actually a picture of the old style because the stakeholders we were working with were only supporting the old style, the deprecated types, and they're looking to upgrade, but at the moment they're only supporting those deprecated types. So there is a switch which you can specify that allows them to create the old deprecated types in this respect, or the new ones. So because this is all about using a repository proxy, then the main part that you would need to be able to do, the only part you really need to be able to do, is configure it. So you have the third-party technology, the Hive Metastore, and then you just need to create a configuration that runs on the OMAG platform. So you create a configuration for an OMAG platform server for the repository proxy, and you give it a name, and it has its metadata collection ID. And this is the standard set of parts of the configuration. So you can see that the bits that are, all of these are pretty standard, because a lot of every server pretty much needs the common services, and there's parts which are used with different types of servers, such as repository services. So in this case, we need the repository services. And it's actually an event mapper and the virtual connection, which is the part which defines the caching connector. So that's where we are when you're looking at the configuration. The event mapper, just to go into a bit more detail, has these various options. So we talked about the prefix that you could apply at the beginning of every qualified name for every entity that we create. You can specify a unique one there, so that if you have another HMS that might have similarly named catalogs and databases and possibly similar named tables, you can make them unique by having a unique prefix. This is the polling interval in seconds. We could consider maybe minutes might be better, but at the moment it's seconds. As a catalog name and the database name, the way that this is coded at the moment is it's for a particular catalog database combination. So you need to understand what those are in your Hive implementation, or what they are in the IBM Cloud implementation, and put them in the configuration. And these are the IBM data engine parameters. So the cloud service that IBM exposes, the data engine service, actually uses SSL to communicate with it, and by default the Hive doesn't use SSL. So if you try to do any testing with Hive, it'll fail if you're trying to use SSL to it, and if you don't specify SSL, you won't be able to connect to the data engine. And also, you need a separate jar file to be able to be the client. But I can talk about that in a minute. So I've got an option here as a flag to say send the poll events, because if you only were interested in exposing, populating a cache and allowing people to query it, then maybe you don't want to send these poll events across the network. So that's an option. Then for the caching side of things, there's a virtual connection, and it has embedded connections. This is a standard pattern that we use in the configuration, and the native repository definition is just a standard definition, is in that embedded, one of those embedded connections. You specify one embedded connection as being the native repository, and that's what all of the calls will get delegated down to. So just having a quick pros and cons. It's much simpler to develop this style of caching style of repository proxy, because you don't need to implement all the searches. You only need to do updates at poll time. So it's so that can be a good or a bad, but you can go down from the top of from the database and catalog that you want, go down, grab all the tables, grab all the columns, and it's a simple way of coding that. So you simply traverse down the third-party technology. You don't need to work out the context of any particular element that might have changed, because we're going down from the top to get all of it. The events are well formed because they use the well-tested repository helpers within the connector. The downside might be that if you had very big HMS content, you had a lot of content there, you could swamp the content with all the content underneath a particular catalog and database every poll. So that could this is really for smaller installations. So this would be quite a limiting thing. If you were to if you needed to use the events seriously for large amounts of data. So another option would be that we could resolve the HMS query to a Hive Metastore query in real time. That could be more performance scalable, but we don't get the simpler development. But that could be an option for larger Hive Metastore systems. And at the moment, there's no delete support. We could check the cache and see what's missing and send out deletes events. At the moment, that is not the top priority to implement. So we may get to do that at some stage, but at the moment we don't do that. And then just to say, how do you run with the data engine on IBM Cloud? Well, they supply a Hive Metastore compatible client as a jar file on the website, the IBM website. So we need to bring that into our build instead of the native jar file. So we have a bash script that that instruments the build and then pushes out, then creates jar files with the IBM jar file, and then you can just use it as you would normally. We're hoping that bash script can go into the open repository. We haven't got confirmation in terms of that could happen. We'll see on that. Just before we go to the last slide, I was going to go back to just now that we've been through the two different styles of connector. I just wanted to contrast them. So this was, if you have a look at what we just talked about, you can see that the event mapper is doing the mapping for the caching one, and talking to the third-party technology, and sending the batch event through to the cohort. And the only interaction that it makes with the repository connector is that it says, it does the ads for all the all the reference copies for the entities and relationships that need to be created. So we do a save entity reference copy for each entity and each relationship that's required, and then that gets cached. So that's slightly different for the traditional pattern, where the event mapper traditionally would actually have events coming in from the third-party technology, but not in the IGC case, because they didn't at the time, they didn't have events coming out for IGC. And we would have so I realize I'm missing a event. There should be another topic for the third-party technology here, and with events coming in. And then when those events come in, they're mapped into the Egeria format. The mapping is done in the repository connector. In both cases, we have a query API. So this is the OMRS API that is used as part of the federated query, or even if it's a non-federated query. So if you want to do a find, a search, or a get, you would be using this API. Both of them expose the same shape of APIs. So this is the standard OMRS one that exposes entities and relationships and classifications. So it's that sort of level, as opposed to if you were to run a higher level access service, you would get a much more tool-centric, access-orientated, use case-orientated, persona-orientated API, where they're only showing you a subset. Here is the sort of down in the weeds of the atoms of all of the metadata, and it's done like this to facilitate these types of integrations. I'm just going to go back to the.
Thanks, David. I can take over the last part. Just one last remark, maybe. We can see with both patterns that Egeria accommodates quite a lot of different, and since it is that generic and modular with the connectors, allows this responsibility to be shifted towards different places or different components, and then get best out of the integration that you're implementing. So I think this is really a powerful thing, and we are proving here with the connectors. A last thing I want to talk about is other known implementations. So we talked about the repository proxy and the two different styles that we have for specific technologies, namely IBM open source and the other one with HMS. But we also have something that is a bit of a legacy, or it started in the same moment where we started integration with the IGC open source proxy, and it's almost the same pattern. So repository proxy for Apache Atlas, open source metadata repository or governance thing. Oops. Sorry, I disconnected a little bit here. Can still see my screen, sorry?
No, we're back to your to just the people on the call.
Okay,
So I think
sorry about this.
Yeah.
I pulled my cable. I will share again and quickly finish. Should be back.
Perfect.
Yeah, good.
Yes, thank you. I was just mentioning the Apache Atlas, who is also hosted under our open source GitHub repo. It is slightly with limited support at this point in time, but as a matter of capabilities that it supports, it is mostly supporting read-only as well. So also there is no support for reference copies, again, coming out of the underlying technology. And but it is still a good example on how we can build proper or complete integration with such an external technology. what I want to highlight here is the other one, which is Microsoft's spin-off of that same code base. It is a similar but more rich and repository connector, which is under development still. So it's now at the technical preview state. It follows the same pattern. So it has the interface it is mostly based on the event mapper interface. So eventing mechanism that is available within the third-party technology, in this case being Azure Purview data governance solution. And what it does is it offers us two-way integration with Event Mapper. So events going in and out of Egeria, but with a note or remark here that it is not complete support for reference copies, but it is just storing everything and not having the notion of immutable copy. So that is something to be probably tackled later on, in regards to making it conformant completely with the protocol and the standard. But still, I think it's a good example, because it also provides a support for federated queries. So really going to that optimal integration approach where in this environment, in this cloud solution, we'll be able to also have integration with federated queries. So that's in work in progress. And of course, this is a commercial part of a commercial solution, the Purview offering as a cloud service. And I think there are plans in future to definitely put it there as a service. More about this, I think we will hear on a separate dedicated presentation. I hope either in these formats or in a different community call. I'll stop sharing at this moment. And that was it for today. Thank you all for attending. We talk about similar interesting things the next time.
So just to say, the next webinar will be in January on how to build a repository proxy.